Hello viewer and welcome to the e-learning classroom. So today we want to look at the pulleys. We have the systems of pulley here. This one has 4 pulleys, and then we have 1, we have 2, and we have 1 which can also be combined with this other one here. So we want to see how these pulleys work. So maybe we can start with this one. So we have the load, and then we have the effort here. You can see how it makes the work easier. So this one has a velocity ratio of 1, which is the strain that is directly carrying the load. So we have 1, the velocity ratio here is only 1, which is the number of strings that are directly carrying the load. In other words, when the effort moves down by maybe 1 centimeter, then the load will also move up by 1 centimeter. So you can see that. So, and for that, we can also consider this other one here. So for this one here, we have a pulley here. We have a pulley here, down here, and then we have the load. Under the pulley, we have a load there. So let's see. So this is what we have now. This is what we have. So if you compare this one with this other one here, you realize now this one is still a single movable. This is a single movable pulley. This one is a single fixed pulley, but you realize that the 2 strings are carrying the load directly. That means the velocity ratio of this one is 2, unlike this one which has a velocity ratio of 1, because only one pulley here is carrying only one string here is carrying the load, but this one we have 2 strings which are directly carrying the load. Remember, we can also combine this one with this other pulley here to change the direction of the effort. So we can also, let's see how we combine with this one. So we have this other pulley here. Want to combine this pulley. The essence of this second pulley here is just to change the direction of the effort, whereby now we want the effort to be applied downwards, like initially when we are applying on the upper side. So that means we have, let's see what we have here. Let's see what we have there. Can fix this string. Yes, like that. So we have fixed that string now. So you can see this one now. So this one has a velocity ratio still of 2. What we have done is only that we have changed the direction of the effort, whereby now we are applying the effort downwards. Initially we were lifting here, whereby now we are applying the effort upwards, but now we have, so this one is still a single movable pulley, because the essence of the second pulley is just to change the direction of the effort. So we can also consider the other sets. Maybe this one I can fix it here. Let me just fix this one here. Might use it later. So let that one stay there. We also have this other set here. This one is still a single movable pulley, but for this case we have this pulley is movable, this one is fixed. The velocity ratio here is 2. We have this string and this string which are directly carrying the load. So those are two pulleys. So we have 2 there. Then lastly we have this other one here. This one has 4 pulleys. This one is a block and tackle. We have 2 fixed pulleys and 2 movable pulleys. Remember, the spring is starting from here. It is fixed here. Then through the first pulley on the upper side, through the second pulley, and through the second pulley on the upper side. So for this, the system will be moving like this. Hope you're able to see that. So this system is able to move like that. You can see that. And the velocity ratio here is 4. You can see that, viewers. Let me return this one here. You can see that. Remember, pulleys are used to make work easier. For example, when you want to lift them, when you want to lift cement from the ground floor, maybe to the upper floor, you can use a pulley to make that work easier. So these are the systems of pulleys we have. This one has a velocity ratio of 4 because we have 1, 2, 3, 4. These are 4 strings which are carrying the load directly. So viewers, it's important to know that when you are working with a pulley, you just need to know how many strings are directly carrying the load, and that becomes the velocity ratio of your pulley just by counting the number of strings that are directly carrying the load. So for example, you have said this one has only a velocity ratio of 1 because only this string is carrying the load directly. So that is 1. You can see that. And then you have said this one has 2 because if you look at the number of strings that are directly carrying the load, we have this one and this one. So we have the 2. Essentially, also it's important to note that when the effort moves 2 meters, then the load will have moved 1 meter. So that's another essence of understanding the velocity ratio. Then we also have this one here, whereby we have seen this one as a velocity ratio of 2. We have seen this one as a velocity ratio of 2, and the 2 is, we are counting this string and this string. We have seen this other pulley here is just used to change the direction of the effort. Then lastly, we have also mentioned something on these pulleys. This one is a single fixed pulley, single movable because of this movable. This one is also single movable. This one is block and tackle, and for the block and tackle, we have 2 fixed and 2 movable pulleys. So the velocity ratio here is 4 because we have 1, 2, 3, 4 strings that are carrying the load, and you can see the pulley system working like that. You can see the pulley belt working like that, viewers. So that is all about the pulleys. Maybe we can see. So viewers, for the diagrams, we have a pulley with the velocity ratio of 1. That is one which has 1 string that is directly carrying the load. Then we have a pulley with the velocity ratio 2. That is 2 strings that are directly carrying the load. Then we also have 2 strings again carrying the load, so velocity ratio 2. Then we have 3 for 3 strings carrying the load, 4 velocity ratio 4, and then velocity ratio 5. There is a block and tackle, and then we also have velocity ratio 2 for the blue colored ones. The second pulley is just used to change the direction of the effort. That means this pulley is similar to the second pulley. Then we have velocity ratio 3. Again, we have 3 strings carrying the load, so the fourth pulley is just used to change the direction of the effort. So that marks the end of today's session. Let's see you in the next video.